So we're asked, is this function a solution of this? I don't know. I don't know because I don't have the first derivative yet, and I don't have the second derivative yet. Once I have them, I will put them in here and the function, try to combine like terms and see if I get 0. If I get 0, I'll come back and I'll say yes. If I don't get 0, I'll come back and say no, it's not. But they're asking us to check. So I don't think that this is a tricky question. So I cannot do anything here before I find y prime and y double prime. So let's find y prime. This is nice, always nice. Careful, this is the product rule again. So plus the first function prime is 3 times e to the x plus the first function times the second one prime, which is still e to the x. I see that these can be combined, and I write y prime equals 4 e to the x plus 3x e to the x. So what do I have for now? I have this. I will replace it in a minute. I have this because I have the given function, but I am still working on the second derivative. So let's find the second derivative of this. Which is the first derivative of this, actually. 4 e to the x plus, again, the same thing, product rule. First function prime, 3 e to the x plus 3x times the second function prime, nice, e to the x. I see that these two can be combined. So this is 7 e to the x plus 3x e to the x. Now I have all pieces ready. This will be replaced by this. This will be replaced by this. This will be replaced by this. And if I don't get 0, then I'm in trouble. So the second derivative, 7 e to the x plus 3x e to the x minus 2 times this. 2 times this is minus 8 e to the x minus 6x e to the x, and plus the original function, which is e to the x plus 3x e to the x. And you know I always run out of room. I have to. That's my legacy. Okay, so we check again. We replaced the second derivative. I multiplied the first derivative by -2. And I copied the original function. And now let's see. If they don't cancel out to get 0, then I have an error somewhere. Okay, so I have a 7 e to the x. I have a -8 e to the x. And I have a positive e to the x. Nice. This is 8 minus 8. Then I have a 3x e to the x, a 3x e to the x, with a -6x e to the x. 6 minus 6, 0 indeed. So I will go back and say absolutely yes. I checked. I determined all this, I put them together, and I did get 0. So this is a solution of the differential equation, an equation that has derivatives in it. Good. So this was just basically a warm-up. Now we want to see if we can solve differential equations. And we will look at very simple methods, something called simple, and the other one is called separable differential equations. So we do not learn other techniques, just very simple situations, and something called separable. When we separate the variables, separate the variables. So let's see. I'm going to share my screen and start with something very simple. Okay, so allow me to choose this time, the first one. and then we're going to look at other examples. So this is, it says, find the general solution of each differential equation, and then check the solution by substituting back into the differential equation. Okay, so again, I'm going to just, they're all the same, as you see, really. They're all the same. We can choose any, doesn't matter. They just have different variables just to throw us off, but they're all the same. Okay, so let's start with 15. So I have dc over dt equals 0.66c. Okay, so what do I notice? So this is a situation in which I have to separate. I have to separate the variables. What does that mean? So I see dc here, and I see c here. I don't want to have c on both sides. So my first step will be, first of all, I will multiply by dt. And you can say, wait a minute, why are you multiplying by dt? This is just c prime. You can consider that too. So if this is c prime and this is the answer, c prime of t, right? Then we have, as I said, this is basically c of t, right? So this left-hand side is c prime of t, the right-hand side is c of t, right? So that's why I have the derivative of a function here, and I have the function here. So it's easier to understand that the two c's have to be on the same side. So I prefer multiplying both sides by dt, because we also know that dc is the differential of c, and we also know that dt is the differential of t. So I am allowed to multiply both sides by dt. So let's do that. So then I have dc equals 0.66c times dt. We've seen this before, right? It's dy equals a function of t dt. This is nothing new. Now I still have c and c on both sides. Now I will divide both sides by c. Okay, so then I have dc divided by c equals 0.66 dt. I separated the variables. T is alone on one side, and c is alone on one side. Remember when we talked about implicit differentiation, we differentiated both sides. Well, in this case, we are going to integrate both sides. So let's look at the easy part. The easy part is here. The other side is easy too. But let's look at this one. What is this? Very simple. 0.66t plus a constant c. What is the antiderivative of this? Or which function prime is this? 0.66t. When I differentiate, I get 0.66. Of course, plus a constant c, because this is not a definite integral, it's an indefinite integral. So now I'm going to cover this side because it may be confusing. So just leave it alone. The integral from dc over c, what do you think we should write? Which function prime is 1 over c? So again, don't look at the right-hand side. Yes, sorry, forgive me.
Is natural log.
Natural log of the absolute value of c, indeed. And now you could say, but you have to write plus a constant here. No, we don't have to write the constant on both sides. And because we have c in here, I'm going to change this to d, because I don't want you to get confused. This is not this. This is just a constant. So I'm going to change this to d, or e, or f, or whatever you want, but not c. So now we are still solving for c. Solve for c. It's not ready yet.
I have a quick question.
Yes?
Where'd you get the t after the 0.66?
Very good. which function prime is 0.66?
Oh, okay.
That's okay. This is probably the most difficult section of the entire course, 5.7. So please ask any question anytime. So I found the antiderivative, or the most general derivative, the general antiderivative of this function. So when we differentiate this, we get 0.66. When we differentiate this, we get 1 over c. So we solved both sides as if they are completely independent. We solved this and we got this. We solved this and we got this. It doesn't matter where you put the constant, but it has to be one constant. Even if I put a constant here, d1, and here d2, when I combine them, I will still get only one constant. So I'm going to write this again because I wrote on top of it. So then we have the natural log of the absolute value of c equals 0.66t plus a constant d. Remember, we are solving for c. How do I solve such an equation? I'm covering it because I don't want you to get confused here. So it's just this is just an expression. Don't look at it. How will I solve this for absolute value of c? So I have natural log of something, the variable, equals a number. Or an expression, it doesn't matter. How do I solve such an equation with the natural log of something equals something else? What is
both sides by e?
Yes, in other words, you're saying e to this equals the absolute value. So we are, if you want to say we apply, but we also, the easiest thing to say or do is e to this plus d equals the absolute value of c. Now, the absolute value of c can be written as e to 0.66t times e to d. Where does this come from? Remember, when we have a to the 4th power times a to the 3rd power, we write a to 4 plus 3. But we can go back. A to 4 plus 3 is the same with a to the 4th times a to the 3rd. This is what I did here. Because of plus of these two terms, it's a sum of two terms, e to this power times e to this power. We are normally changing this into a constant. I'm going to call it e. So then the absolute value of c equals e times e to 0.66t. And then c equals plus or minus e times e, e times e to 0.66t. What does this mean? It means that this function satisfies this differential equation. If I differentiate, and that's what they want, if I differentiate both sides, I should get dc equals 0.66c times dt. So that's the idea behind solving a differential equation of this type. So find the general solution. We did. And check the solution by substituting into the differential equation. We can do that right now. I know you probably have a lot of questions, and we're going to look at other examples in a minute. So let's differentiate this. dc over dt equals. So when I differentiate something like this, right, the constant stays in front, times e to 0.66t times 0.66. And again, this is just a constant times 0.66. Any questions on what we just did? Would you like to look at another example?
I have a quick question.
Yes.
Where did you get that final 0.66 from?
When we differentiate e to a function prime, we write e to the function times the function prime. So when we differentiate the power, which is the function, in this case, I get 0.66.
Okay. Thank you.
Thank you.
Professor Lee,
Yes.
was this an example for simple or separable?
Well, it can be. I worked on it as a separable differential equation. So let's find if it's a very good question. Let me also look at a simple one.